All right, welcome back. Video number 2. I lost my pen here. There we go. Okay, so I want you to be on page number 3 of the lecture notes that I had you copy down yesterday. And you should see a problem that looks something like this, but yours is already filled in. So I made a new one on a smart notebook, same problem, and I'm going to walk you through it. I think it's easier for you to follow if I build the problem rather than just, have it already worked out in front of you. So here we go. And I'm not going to go I'm going to go slow enough, but you can, since it's on video, you can pause this and whatever. So, okay, so the first thing, you have your diagram. Here's your schematic circuit, your series circuit. A 4 ohm resistor, a 6 ohm resistor, and an 8 ohm resistor. So typically what we do first, if you notice down here, there's a table, all of the resistances, all the voltages, and all the currents. So I'm going to put down in here what I know already. Here's a 4 ohm resistor, here's a 6 ohm resistor, and an 8 ohm resistor. I also know there's an 18 volt battery. Okay? Everything else we need to find. The first thing you do in determining or breaking down a series circuit is to find out what the total resistance is. So you'll go to your first page of notes, and what do you do? How do you find the total resistance in a series circuit? Well, if you remember, you add them up. So we're going to have 4 plus 6 plus 8 equals 18 volts. 18 ohms, sorry. Okay? So, then you're going to go straight across the table to the top, and the total current, which I think is point number 3 on your lecture notes, is Ohm's law. It's just VT over RT, which is 18 volts divided by our newly found 18 ohms, and so we have 1 amp of current. Okay? Now we have 6 things left to calculate. But to be perfectly honest with you, 3 of them really require no calculation. Can you determine which 3 of the 3 volts or the 3 currents really doesn't require any calculation? And you're right if you said the current. Why? The current's the same everywhere in a series circuit, and it's equal to the total. So this is 1 amp, 1 amp, and 1 amp. And what I typically have students do on a test is to make a little bracket here and just write, that's a characteristic of a series circuit, so I don't need to show any work. So it tells me that you know what you're doing. Okay? So then we really have to do is find these 3 voltages. Remember, in our first video, we called these the voltage dropped. So the voltage dropped at number 1 is found by taking, remember the equation, this is in step number 4, it's I1 times R1, which is I1 is 1, R1 is 4, which is 4 volts. Same thing at number 2. It would be I1 times I2, sorry, my fault. I2 times R2, which is 6 volts. At number 3, we're going to take I3 times R3, and we get 8 volts. Step number 5 in your notes was, does the voltage add up to, or does your individual voltage drops add up to your total? Does 8 plus 6 plus 4 equal 18? And the answer is yes, we do. It does. And that's it. That's how you solve what looks like a fairly complicated problem. That's how you go out and solve it. And on the test in person, this test, you know how we have mostly multiple choice questions and then there's a few problem solving questions? In this test, it's just reverse. It's almost all problem solving like this. You would have a series circuit problem, virtually identical to that. a parallel circuit problem, which we're going to introduce tomorrow. And then we're going to do a hybrid circuit with both series and parallel in the same part of the circuit. And that would be your third problem solving question. But each of these are worth 5 points. But I haven't decided how we're going to go about testing that. I might just pick out parts of a problem like this, and you may still have to solve it, but then a multiple choice answer for like, what would the voltage drop at number 3 be, for example? And that would be your question on the test. Okay. So anyways, this is your second video. There's a concept builder for today. Hopefully you enjoyed that concept builder. It's just some practice in doing just this stuff. Refer to your notes. There's no homework today. Yay. So you can refer back to your notes, refer to the videos, work on the concept builder, and tomorrow we'll pick up the parallel circuits, which is a little more challenging, but you're certainly capable of doing it. So hope you have a good day. Too bad it wasn't yesterday where you didn't have any homework when it was nice and sunny out, but today looks like it's going to be kind of a washout until late afternoon. So get out this afternoon and enjoy the evening.